Hello and welcome everyone to CS 439 Introduction to Data Science. My name is Aishwarya and I am your recitation instructor. I am going to introduce myself to you. So, my name is Aishwarya Harpale. You can call me Ash if that is difficult for you to pronounce. That's completely fine. My preferred pronouns are she and her. My email ID is aishwarya.harpale@rutgers.edu. I will be sharing it with you. And I am a first year master's student and I am doing my master's in computer science. You can reach out to me during my office hours. I'll declare my office hours soon and we will be in contact regarding any doubts you have. And that's all about me. Thank you.
Hello everyone, my name is Karan Pardasani and I will be your recitation instructor for the course of Introduction to Data Science. And I will introduce myself. So, my email address is karan.pardasani@scarletmail.rutgers.edu and I am first year master student in computer science department and my area of specialization is machine learning. My office hours will probably be declared next week, but if you have any issue or have any difficulty in any topic, you can meet me during my office hours. And if my office hours are clashing with your course schedule, then you can email me and we can set up a Zoom meeting, or if you want to meet in person, then also we can meet in my office. And just feel free to mail me if you have any problem or any difficulty in topic and if you want to meet me. So in the first recitation, I am going to tell you the steps that you will have to do to install Anaconda with Python and Jupyter Notebook setup. And before that, I will give you some information on Python, Anaconda, and Jupyter Notebook. So Python is a computer programming language and it is an interpreted language. So interpreted language means that the code is compiled and interpreted during the execution. You might be familiar with languages like C++ and Java. So in those languages, what happens is that whenever we want to run the code, we first compile the code and then the machine runs the code. So there are two stages to run the code. First, the code is compiled and then it is executed. But in the case of Python, there is another component called interpreter. The interpreter compiles and interprets and executes the code in a single step. What it means is that the interpreter will take first statement of Python. It will compile that statement and execute that statement. Then it will take the second statement. It will compile that statement and execute that statement. And in this way, there is a single stage for compilation and execution. But in C++ and Java, there are two different stages. The compilation is done by compiler and the execution is done by machine. So this is the difference between interpreted language and compiled language. And also Python is very easy to use and learn, and it is one of the popular language that is relevant in data science industry. So in this course, we are going to use Python for our lab assignments. Python has two versions, Python 2 and Python 3. We will be using Python 3 since the support for Python 2 was stopped from the year 2020. And there is also the distribution of Python package known as Anaconda. It is a very popular software distribution which contains over 150 data science packages. And it also contains Conda, which is a package manager that helps in installing, updating, and removing packages. So if you don't know about package, then package is just like the library that we use in C++ or Java. So the purpose of the package is to reuse the code that is already written in some other file. So like if we want to sort our array, then we will, let's say the numpy is a package and it has a function for sorting an array. So we will use the sort function, the code of the sort function that is written in the numpy package, and that and so the packages have code that are pre-written in it, and we can just import that package in our local file and use that code. So that helps us in shortening our program, and it is very useful in big projects. So Conda is a package manager in Anaconda that helps in package handling. Also, Conda helps in environment management. So the environment management is used when you want to build multiple projects in a single laptop. Let's say you want to build let's say you have two projects, and one project requires two different versions of sorry and let's say two projects requires two different versions of NumPy. The first project requires NumPy 12.0.8 and another version requires NumPy 10.0.2. Then for two different version of NumPy to run in the same system, you will need two different environments. So the environment are useful to isolate the different version of packages that we want to use for two different projects. So Anaconda and Conda also helps in the environment management. If you want to install any package using Anaconda, then there is a simple command you have to write in command line: conda space install space the name of the package. Also, there is another package installer for Python known as pip, and to install a package using pip, you have to write pip space install space package name. And in Anaconda, there is a tool called Jupyter Notebook. It is a web application in which we will write the Python code. So it is similar to the C++ Java IDE that we use, that are like Visual Studio and IntelliJ, but it has more features than simple IDE. So it has features like interactive graphs. So interactive graphs, by interactive graphs, I mean, like, let's say you want to analyze a graph where you are changing a variable and you want to see how that particular graph changes. So in Jupyter Notebook, you have some particular widgets that you can use to create interactive graphs. And so you can actually change the value of a variable and the graph will change accordingly. And in that way, you can study the graphs in interactive way. So it is a very beautiful feature that can be used for data analysis, and hence Jupyter Notebook is very popular when it comes to build data science projects, and we will use Jupyter Notebook for writing the Python code. So yes, so this is the use of Jupyter Notebook. So now I will show you how to install Anaconda. So to install Anaconda, yes, to install Anaconda, we need to search Anaconda documentation, and in that we will go to the first link. There we scroll down and we go to Anaconda individual edition, and then we click on installation on the left pane. Then we have three different options for three different systems. For Windows, I will select the first option, and for Mac OS and Linux, you can select second and third option. So after clicking on first option, I will click on the link where it says download the Anaconda installer, and then I will click this button. I have already downloaded the Anaconda installer beforehand, so I will open that folder. So this is the folder that contains Anaconda installer. So I will double click on it to start the installation. And I will receive this screen. First I will click on next. Then I will agree to the terms and condition. Then since the Anaconda is for personal use, so we will select the first option, then click on next. Then this is the destination folder. I generally don't change the destination folder because in the future when you have to do any configuration change, then you will have to go to this folder. But if you want to change this path, you can change it, but then remember it when you want to do any configuration change. So since I don't change it, then I will simply click on next. Then I will tick this first box. It is very important to tick this first box because if you forgot to do this, then the Anaconda 3 will not be added to the path environment variable, and it will be difficult. So your application will not run, and it is important to add the Anaconda 3 to the path environment variable. So you tick the first box and then click on install. It will take a few minutes to install. So I will pause my video and until it gets installed. So the installation is complete, and now I will click on next. Click on next, and then I will click on finish. So so now I will search Anaconda Navigator in the start menu, and I will click on the application. It will take some time to open the application. So this is the window for Anaconda Navigator, and then for Jupyter Notebook, we will click on Launch. So it will launch the Jupyter Notebook, and it will open the notebook in the browser. So since it is a web application, it will open in a browser, and I can click on new. I can create a new folder, and I can create a new Python file. And I can import packages. So NumPy and Matplotlib are already installed. So now I will show you how to install packages using pip and conda. So in the start menu, you write cmd and press enter. So or you can search for command prompt and you can open the application, and in this window will open. So I so uh, before showing you the pip and conda commands, so if you want to check the version for Python, the command is python minus minus version. So this is particularly important when you want to check some like when some packages are not working. It is very important to check which Python version the package is compatible with. Like there are some packages that are not compatible with some version of Java, with some version of Python. So do check from documentation of package which version of Python it is compatible with, and also check your Python version. And if you want to know where you have installed the Python, then you can type where Python, press enter, and you will get the path where the Python application is installed. So these two are the commands. Now, if you want to install pip, then it is pip install numpy, and since it is already installed, then the requirement is already satisfied. But if you want to install using Conda, then Conda install matplotlib. So this will install matplotlib using Conda. Okay. Yeah. So the matplotlib package was installed, and now I showed you how to launch the Jupyter Notebook from Anaconda Navigator. So you can also launch Jupyter Notebook from command line, and I prefer this method from command line because uh, it is easier and faster to open using this method. So you just have to type Jupyter space notebook, press enter, and in the command line, the localhost 8889 this on this server, your Jupyter Notebook is working, and you can check in the browser that in localhost 8889 our Jupyter Notebook server is running, and here you can check our Python file that we made previously, and this is the code that we wrote. So in this way, you can open the Jupyter Notebook from command line. So these are the steps that are involved in setting up the environment for your assignments, and you can use Jupyter Notebook to write the code for the data science algorithms. And if you have any issue in your setup, like I understand the different systems have different configuration, and like there might be some issue that is not covered in this video, then feel free to come during my office hours in my office. My office hours and the location will be shared to you as soon as possible, and just come to me and we can set up your system for the assignments. And yeah, that's it from me. And if you have any question, you can ask me when we meet. Thank you and bye.
So let's go through this notebook over here. We're going to look at how to use the Python library NumPy and a few examples of matplotlib. So let's start with NumPy. Now NumPy stands for numerical Python. Here we are importing the library, import NumPy as NP, where NP is an alias for NumPy. So every time you don't have to write NumPy, the whole word, you can just use the alias NP. And using this statement, we import NumPy. We shall run this line. Now we are going to create a 1D array using NumPy. So we use the function np.arrange 0, 10, which simply says that I want an array which includes the digits from 0 to 10, where 0 is included and 10 is not included. So the first index is included and the ending index is not included. So we'll get the digits from 0 to 9 in an array. So when I say a equal to np.arrange 0, 10, I will get an array which with digits from 0 to 9. When I do print a, I will get this array, and when I say print the type of a, it will be a numpy array. So when I run this, it will give me the digits 0 to 9, and the type of the variable a will be numpy.nd array. Next, we're going to see how to get a NumPy array which you want pre-filled with zeros. So using the function np.zeros, we can get an array which is filled with zeros. What is 3 in np.zeros? 3. So this 3 is the length of the array. So when I say np.zeros 3, I want an array of length 3 containing all zeros. When I say np.zeros 3, 5, I will get a 2D matrix of 3 rows and 5 columns containing all zeros. So when I run this particular cell, you will see that the first output is a 1D array of length 3 containing zeros. The next is a 2D matrix of 3 rows and 5 columns containing zeros. Now, if I want to reshape this array, so I will use the function reshape. So when I say C, this particular matrix C dot reshape 5, 3, it will reshape this array from 3 rows to 5 columns. No, it will reshape the array from 3 rows and 5 columns to 5 rows and 3 columns. So here it will become a matrix of 5 rows and 3 columns. And remember, in np.zeros, if you want to give the dimensions of a 2D matrix, you have to give it in double brackets. So don't commit this mistake. What if we want an array containing random numbers? So we use the function np.random.random. Using this particular function, we get an array of length 3 containing random digits. So np.random.random3 will give me an array of length 3 with random digits. When I print this, I will get random numbers. Again, if I run this, every time it will give me random numbers. Now, how do we convert a list to a NumPy array? We simply use the function np.array. So over here, we have used np.array equal to 2D matrix 1 to 4, which is the first row, and 4 to 9, which is the second row. And d type is equal to int. It's nothing but the data type of the array should be integer. So if we print this, we get the array, we get the matrix 1 to 4, 4 to 9. If I want to add another row over here, I will simply put in, let's say 3, 6, 9. If I run this, I will get another row in this, 3, 6, and 9. To convert tuples to NumPy arrays, again, it's a simple, we again use the function np.array, and we will simply insert our tuples into this particular function. So we say np.array, I put in the tuples over here, 1, 3, 2, 8, 4, 5. Each tuple will be on a new row. So when I print this, I will get this particular array, 1, 3, 2, 8, and 4, 5. If you want to get the shape of a NumPy array, we use the dot shape function. So this particular array has 3 rows and 2 columns. So when we print g dot shape, we get 3, 2. Let's say I add another tuple to this. Let's say I add 6, 7 and run this. So over here you can see that in this array 6, 7 and another tuple has been added, and the shape of this array is now 4, 2, which means 4 rows and 2 columns. Now, what if you want a matrix or a NumPy array which is filled with a particular constant value? We use the function numpy.full. So the syntax of this particular function goes like np.full, then we give the dimensions of the matrix that we want. So over here 2, 5, and then the constant value with which we want to fill this with. So np.full 2, 5, which is 2 rows and 5 columns, and the constant value 9. So and when we print this, we get a matrix of dimensions 2, 5 with number 9 filled in it. So if I want to fill this with, let's say, 45. And when I run this, I get a matrix filled with the number 45. Next, let's look at the arrange function again. So this using this arrange function, we can get a sequence of values between two endpoints, and we can also specify the step value of this function. So np.arrange, and the syntax of this particular function, it goes like np.range start index, end index, and step value. So 0 is our start index, 20 is our ending index, and 3 is our step value. So when I print np.arrange 0, 20, 3, I will get an array with digits from 0 to 20, and each digit that I get, each value that I get, will be incremented by 3. So that is the significance of our step value. So our first index is 0. The next value will be 0 plus 3. So a step by 3. And therefore, our array will progress like 0, 3, 6, 9, and onwards. Now this array, it won't go beyond 20 because 20 is our ending value. And in such a way, you can create step valued arrays also. Now let's look at linspace. When we use linspace, when we want a linearly spaced array with certain number of values. Now, how does linspace differ from arrange? Now, where the syntax of this one goes something like start index, end index, and number of digit. So over here, using np.linspace, we are specifying the starting number, which is 0, the ending number 20, and 11 is the number of digits that I want between 0 and 20. And all these digits will be linearly spaced. So if I print this, I will be getting 0 to 20, and you can see that the length of this array is 11. I'm going to just print j.shape for you. So here we see that it contains 11 digits. So with linspace, you specify the number of digits, specify the number of numbers that you want in that array. But in arrange, you specify the step value with which you want to increment each value. Now let's look at a few mathematical operations on this array, on NumPy arrays. So we have our array J, which contains values from 0 to 20, 11 values. And I want to subtract 3 from each of these values in the array. So I will simply do J minus 3. And when I run this, from each value, we have the number 3 subtracted. So 0 minus 3, we get minus 3. 2 minus 3, we get minus 1. I can do any operation of it. Let's say I subtract 20. It will subtract 20 from all the digits. Similar to subtraction, you can do addition. So I did j plus 20. It will add the value 20 to all the numbers. So again, it went from 0 to 20 to 20 to 40. Just 20 added. You can similarly do multiplication. So j into 3 should give you a multiplied array, and j divided by 3 will give you the division value. Again, the division will result in floating point numbers. So here we go. This is a much cleaner array. Let's just divide it by 2 over here. And this is how you can perform all sorts of mathematical operations on all the values of the NumPy array. Simply add, subtract, or do whatever operation that you want to do. And over here, now let's look at another example. Here we have k, which is j into 3, l, which is j plus 1. So we multiply every value in j by 3 and we add 1 to each value. When we print these arrays k comma l, we get their answers. So j into 3 will be 0, 6, 12 up till 60, and j plus 1 will be 1, 3, 5 up to 21. Now we can add, we can perform mathematical operations on these both arrays too. So k and l, I can do k plus l as 0 plus 6, 0 plus 1, which is 1, 6 plus 3, which is 9. So the mathematical operation is applied on all of the elements of the array. So similar to addition, you can have any mathematical operation you want here. Subtraction, we get the difference between these two arrays. We can do multiplication, we get the product of these, and just like that, any mathematical operation you want. Now let's move on a bit to matplotlib. So matplotlib is majorly used for plotting your graphs, your figures in your Jupyter Notebook. And here, so to use matplotlib, we simply import it as import matplotlib.pyplot as plt. Again, plt is your alias. Instead of writing the whole word matplotlib.pyplot, you can simply use the alias plt to use the library anywhere. And we write percentage matplotlib inline to tell the notebook that we want whatever graphs that are created by matplotlib within the Jupyter Notebook. If you don't write this line, you might get a separate window which will show these plots. So to get these plots displayed in the notebook, we will use matplotlib inline. Now let's try plotting a simple graph. Here x is where we're gonna specify x, which is an array of numbers from 1 to 11, and y, which is another array. So these are your values on your x-axis and your y-axis. And when we do plt, which is matplotlib dot plot, which is the function we use to plot values, x comma y, we will get this particular plot. Let me just change a few values. Let's put 12 over here. Let's put 5, 15. Let's put 7 over here. If we change these values a bit, the graph changes. So using these two arrays, you're basically specifying the coordinates of the points which you want to be plotted on the graph. So your first point will be 1, 2. So which is over here. Next point will be 2, 4, which is this one right here. The third point will be 7, 6, which again we get at 7, 6. So using the plot function, you can specify the x values and the y values and get your graph plotted. Now let's look at a bit more functions that you can use in matplotlib. Now, x is equal to np.sort x. Sort is nothing but a sorting function. When you do np.sort x, it will sort the array x in an ascending order, and np.sort y will sort the array y in an ascending order. So using the sort function, we're simply sorting these arrays in ascending order. If you print these, you're gonna get the sorted array. Let me just run this again. Since we changed our values, it is, you'll get x, this is 1, 2, 5, 7, 9, and 11, and y, which is 2, 4, 6, 9, 12, and 15. It's a sorted array. Now we will plot these values saying plt.plot x comma y, and we will get this particular graph over here. Now plt.xLabel, which is nothing but the value, the label that you want on the x-axis. So the label of x-axis that I'm putting over here is simply x label, and plt.ylabel, we can write it as using this function. You can give the y-axis a label, which will be y label. So you can see Y label, which is printed over here. Using plt.title, you can give the plot a title. So over here we've put the title as simply this is the title, and you will be able to see the title of the plot over here. And next we will go to plt.axis. So the syntax of axis will simply be xrow, xcon, not really xmin, sorry, xmin, xmax, ymin, and ymax. So what we are doing here is simply specifying the minimum and maximum value on each axis. So plt.axis 1, 10, 3, 8 is basically giving us the maximum and minimum value on each axis. So the minimum value on x, the least value on x-axis will be 1, the maximum value on the x-axis will be 10, the minimum value on y-axis will be 3, and the maximum value on the y-axis will be 8. So as we see over here, let me just comment this. And here you can see it. X-axis will range between 1 to 10 and y-axis will range from 3 to 8. So that is how you use the plt.axis function. Now xtext. Now for example, if you want to label certain points on the x-axis using different labels, so for that you can use plt.xtext. So it will change the values 1, 2, and 6 to these values a, b, and pi. And yes, please use this escape sequence for writing pi to get the value of pi. So when I run this, 1, 2, and 6 will be changed to a, b, and pi respectively. So instead of 1, we see a. Instead of 2, we see b. Instead of 6, we see pi. So similarly, like xtext, you can use ytext also. So let's try this with ytext. We shall put it as 3, 4, 5, as let's put in P, Q, and R. There we go. So these particular values have been relabeled to P, Q, and R. So you can use the xtext and ytext function in this way. Now let's look at one more example. So we're using the function called plt.figure to create a figure in matplotlib, and we're specifying the size of this as 20, 10. So fig size is nothing but the size of the figure in inches. 20 is the width and 10 is the height. So every time we specify the x-axis before, so that is our width and height. So we're creating a figure, plt.figure with the figure size 20, 10, and we're creating a subplot in this figure. So this subplot, so how does the index of this go? The syntax of this go, I'm sorry. So this will be num of rows. I'm just gonna write num rows, num columns, and index. So we're creating a subplot with 1 row, 3 columns, and index is the index of the plot, the subplot that we're going to access. So plt.subplot 1 row, first row, which 1 row, 3 columns, and index 1. So the first subplot in this will be, we're accessing that one, and in that we're gonna give the x coordinate. So we're using np.linspace -10, 10, 100. Now remember, linspace will give us values from -10, which is the starting index, to 10, ending index, and the number of points that we want between these two numbers. So we want 100 points between -10 to 10. So X will consist of 100 points from minus 10 to 10, and we're specifying Y1 as X into 2. So whatever will be the value of X, Y will be simply X into 2. And we plot X and Y1. So when we plot this, we get this particular graph. Let's see if I can fit this into one page. Yes. Let's reduce the size of this. Didn't work. Now, right. So we get this particular graph, which is a linear graph. So we can see that X ranges from minus 10 to 10, and X into 2 should range from minus 20 to 20. So that is your Y, X into 2. It ranges from minus 20 to 20, and we have plotted these points linearly. Now, if you want to access the remaining subplots in this particular graph, we will say plt.subplot 1, 3, 2. So we're accessing the second index in this subplot, and we're just going to specify y2 as x raised to 2. So we use this double multiplication sign as an exponent sign in Python, and x will be raised to 2 to the power of 2. So when we plot these two plots, we get two plots here. Power to the root 2 should give us a parabola, and we get that graph. And so we see that over here we have one row and three columns, and we have used two of these columns using the index 1 and 2 to draw these two particular graphs, to plot these two particular graphs. And now we'll use the third index, saying plt.subplot 1, 3, 3, and we'll simply write y3 as x raised to 3, and then we'll get that particular graph, which is a curve, another curve that we have. And since our y3 is x to the power of 3, it will range from minus 1000 to 1000. Over here, our y ranged from 0 to 100, because it was a square of x, and our x ranges from minus 10 to 10. And over here, the coordinates are now from 0 to 100. So in this way, you can access these subplots and use, say, and divide one bigger plot into smaller plots so that they are comparable. And that's it, I think, for today. So we have covered NumPy and Matplotlib today. We have covered basic mathematical operations on NumPy arrays. We have covered some basic NumPy functions, array, arrange, linspace, zeros, full, and we have gone over a few basic graphs using Matplotlib. We will, if you have any more doubts, you can reach out to me on my email, or we'll be holding office hours soon. And let's hope we can solve more doubts you have about this in those office hours. And yeah, that's it. That's it for today. Thank you, everyone. I'll see you next time.